Hello everyone. Today we're going to be looking at properties of logarithms. The key to this is to remember that a logarithm is an exponent. If we go back to the definition, it's the exponent with which we raise b to get y. So remember, it is an exponent. So we're going to let u equal log base b of x and v equal log base b of y. By definition, this means x equals b to the u and y equals b to the v. So by rules of exponents, we have that x times y equals b to the u times b to the v, which equals b to the u plus v. By definition of logarithms, log base b of x plus log base b of y equals u plus v, which by the definition is log base b of xy, because b to the u plus v is xy. So that makes this part true. This part is true by definition. So log base b of x plus log base b of y equals log base b of x times y. So a log plus a log equals a log of the product. Similarly, we have x divided by y equals b to the u minus b to the v, which equals b to the u minus v, which leads to log base b of x minus log base b of y equals u minus v by definition, which equals log base b of x over y. Again, b to the uv equals x over y. So by definition of logs, we have this. By how we defined u and v, we have this. So if I have a log minus a log, that's equal to a log of the quotient. And then lastly, we have x to the n equals b to the u to the n, which equals b to the un by definition, by rules of exponents. So if I'm looking at n times log base b of x, this is by definition u times n, which by rules of logs, by definition of the log, is log base b of x to the n. b to the un is x to the n. So again, that gives us this part. By definition of u gives us this part. So what this means is that if I have a coefficient outside of a log, I can bring it in as an exponent, or vice versa. If I have an exponent inside my log, I can bring it out as a coefficient. So we're going to do some practice with these rules of logs. So first we're going to condense our logs. So write the following as a single logarithm. This is more important than breaking them apart. If I have one log and I want to write it as multiple logs, so that's sometimes the problem, but 95% of the time we want to go backwards. We have multiple logs, like these guys, and we want to write it as a single log. So that's what we're going to do here. So for A, we have log base 2 of 4 plus log base 2 of 5. The addition of logs means that we're going to multiply our arguments. So it's log base 2 of 4 times 5. And 4 times 5 is 20. So I've gone from 2 logs to a single log. Notice the bases have to be the same. It was always log base 2. That doesn't change. So let's look at B. Negative log base 9 of 36 plus log base 9 of 12. I'm going to rewrite it so that it looks more like one of our rules. So log base 9 of 12 minus log base 9 of 36. And when I'm subtracting logs, that becomes a division inside of the log. So log base 9 of 12 divided by 36, which I simplify down to log base 9 of 1 over 3. Okay, so let's move on to C. Log base b of x squared minus log base b of root x. Again, I've got subtraction, so that's going to become division inside my log. And so I get log base b of x to the 3/2. And then I'm going to bring that exponent down in front as a coefficient. So log base b of x to the 3/2 becomes 3/2 log base b of x. And then as our last one, let's look at D. 2 log base 2 of 3 plus 3 log base 2 of 5. Before I can do the fact that I'm adding logs, I have to make sure that it's a single log plus a single log. So the fact that I have a 2 and a 3 out front means I can't do the addition yet. Remember order of operations. I have to do the multiplication before I can do the addition. So I'm going to bring my 2 in as an exponent and bring my 3 in as an exponent. So it becomes log base 2 of 3 squared plus log base 2 of 5 cubed, which is log base 2 of 9 plus log base 2 of 125. And now I've got the addition, so that's going to become multiplication. So log base 2 of 9 times 125, which is log base 2 of 1125. Okay, so those are some really nice examples of going from multiple logs to single logs. Another thing we're going to look at is just a couple of basic definitions that come up from using what logs are. So they're really nice things to simplify. The first one is log base b of 1. No matter what b is, this is always the same number, which is 0. And that comes from the fact that any number to the 0 is 1. Another one is log base b of b. So it's the same number. Sorry, b and b. G is not supposed to be underlined. So as long as it's the same number, again, it's always going to be the same thing, which in this case is 1. And that's because b to the 1 is 1, no matter what the b is. And the last one is log base b of b to the n. By definition and the rules of rules of logs, this is n times log base b of b. But we just said that log base b of b is 1. So we get n. So this is a really, really nice rule of logarithms or consequence of logarithms that we're going to take advantage of whenever we can. If I can write my argument as my base raised to a power, I can simplify it really easily. So we're going to do a couple examples of using that. So determine the exact values. We're not going to use a calculator, but we're going to know the values of these logarithms. So for e, we have log base 2 of 1 over 32. And I want to look at 1 over 32 and say, can I put that as my base, which is 2, to a power? And I think, well, yes, I can. The 1 over means that the exponent I'm looking for is negative, and 2 to the 5th is 32. So 2 to the negative 5th has to be 1 over 32. So I'm going to rewrite this as log base 2 of 2 to the negative 5th, which means that the log base 2 of 2 to the negative 5th is just negative 5. So there is an exact logarithmic answer. No calculator needed. For f, we have 8 times log base 3 of the 4th root of 27. So I'm going to first rewrite what the 4th root means. And it's 8 log base 3 of 27 to the 1/4. And then I look at my base, which is 3 of my logarithm, and the base of my exponent, which is 27. And I ask myself, can I write 27 as a power of 3? Yes, I can. So I have 8 times log base 3 of 3 cubed to the 1/4. I've got a something to a power to a power. So if you remember rules of exponents, I multiply these two numbers together, and I get 8 times log base 3 of 3 to the 3/4. Log base 3 of 3 to a power is that power. So I have 8 times 3/4, which is just 6. Okay, so you really want to use this rule here. We're going to see it come up a lot in the coming sections. It's going to be really, really helpful. So read through the book, try out the homework, and let me know if you have any questions. Good luck.